two more questions to finish off the assess in chapter 7, properties of polygons. This is question 12. It's a bit involved, but not too bad. Grade A rated. Here we go. I'm told that A, B, C, D, E, F is a regular hexagon. I can see that. I'm told that these two here are squares, and I've got to prove that this triangle here, AHJ, is equilateral. In other words, I've got to prove that all these angles are 60 degrees, or at least prove that one of them is 60 degrees, but we'll see how it goes. So essentially I need to work in this area here around the vertex A, and if I do that, then I could get some angles in place and we'll do some further proof. So first step, let's just work out what this angle A is going to be, and then we'll go from there. Well, it's a regular hexagon, so first we're going to do the exterior angle of a hexagon. So let's write the word hexagon here. So I'm going to do the exterior angle. Always start with that. What is it? It's 360 divided by 6. So the exterior angle is going to be 60 degrees, and therefore the interior angle is going to be 180 degrees. Take away the 60 because they're on a straight line. There you go. Interior, exterior, all on a straight line. Exterior, interior. Okay, and that's going to give us 120 degrees. So I'm now going to put 120 degrees in my diagram. Now let's just change colour because I'm told these are squares. It says so. So therefore that's 90 degrees. So I'm going to put 90 there. I'm going to put a 90 there as well. That's 90 degrees as well. Now look, I've got angles at a point adding up to 360. So therefore I can work out the angle HAJ. Let's see what we get. HAJ, put a little hat on that to show it's an angle, equals 360 degrees. Take away the 120, take away the 90 from one square, take away the 90 from the other square. Let's see what we get. Blah de blah de blah. That will be exactly 60 degrees. I know that because I can see it. So, and I've proved it. Just grab your calculator or do it in your head, do whatever you want to do, and prove that's 60 degrees. So I'm going to put a different colour here. Hopefully it will stand out. 60 degrees. That's 60 degrees. Now that doesn't yet prove that this is in fact an equilateral triangle. However, we're told that AH is the side of a square and AJ is also the side of a square. And if I have two equal sides and a 60 degree angle, the other two angles must also be 60 degrees. Now I've got to communicate that to get my mark. Alright, so this way to do it. AH equals AJ. Alright? And I'm going to say since 60 degrees is made by the sides AH and AJ, angle AHJ, that one right here, equals AJH, in other words that one, which are also 60 degrees. Therefore, if I've got three 60s, I've got an equilateral triangle. Therefore, triangle, what's it called? AHJ is equilateral. Is that okay? Got the logic there? Just thinking it through. Okay, I've proved that's 60. If these two lengths are the same, and that's a 60, the third length must also be the same, because it can't be like, I don't know, it can't be like 70 there and maybe 50 there, because if that was the case, this length will not be the same as this length and this length here. So I've proved that that's in fact an equilateral triangle. Again, think it through nice and slowly. Last question. Quite tricky, I think. You've got to think outside the box or outside the polygons. So the diagram shows a regular pentagon, that's that one, and a regular 10-sided shape, a decagon, that's that one, and they're joined at the side X, Y. In other words, they share a common side. So straight away you should think to yourself, you're the same as you and you're the same as you for the decagon, but also all you lot are the same as well. So it's very, very important to do that. And look, I've created two branches, two sides of a triangle, and I know this triangle's going to have to be isosceles. Now, if I know that's true, just draw a dotted line across there, because I need to prove somehow that A, C and B all sit on the same straight line. So I need to work around this region here to work out the angle around X into this isosceles triangle that I've created. And here I've proved it's isosceles from the information that I've been given. If I can work out some angles here, and that angle ABC, it comes to 180, therefore it must be a straight line. So let's begin to play. Let's just do the decagon in blue. So here I go, exterior angle, usual trick. I've got 360 degrees over 10, well that's 36 degrees. So I'm going to say the interior angle, that's going to be 180, take away the 36, that's going to give me 144. So I know this is 144, alright? The interior angle of a regular decagon. Do the same with the pentagon, just change colour to red. So essentially I want this. If I've got that, and I've already got him, I've got X, haven't I? As part of this isosceles triangle. So pentagon, here I go. Exterior angle. We've got 360 over 5. And that's going to give me 72 degrees. So the interior angle is going to be 180. Take away the 72. 108 degrees, so I know my blue angle is my red angle is 108 degrees. So I'm now going to find this angle here. I better change colour, do it in yellow, it stands out well. I want that part there. Well, I have to call that angle BXC, don't I? Alright, so BXC is going to be 360, because again angles at points there come to 360. Take away the 144, take away the 108, and that will give me something very special, I'm sure. So 360 take away 144, take away 108, comes to 108. Wonderful. Okay, 108 degrees, mysteriously enough. So angle X here, or rather BXC, is 108. So if that's 108 and this triangle is isosceles, I could work out angle XBC. Alright, so let's just put in a different colour there. Green's alright, so these are isosceles, or rather these angles are the same because the triangle's isosceles. So I'm going to work out angle BXBC is going to be 180 degrees, take away the 108, and then divide by 2 because I've got two angles the same size. So that's going to give me 72. Divide that by 2, and that's going to give me 36 degrees. Alright, so let me just label this in black, this is important. So that is 36 degrees, and we know this angle is also 144 degrees because it is the interior angle of a decagon. Now look, let's just do some proper grade A setup. So ABX, okay, so that's this angle here, plus XBC, that's that one there, equals ABC. Is that alright? So this angle plus this angle makes that angle. In other words, that one across there. So what have we got? I've got 144 degrees and I've got 36 degrees. That comes to 180 degrees. Therefore, angle ABC equals 180 degrees. Therefore, show the points. Therefore, the points, not it, excuse me. Therefore, let's write it out properly, quickly. Excuse me. Right. Therefore, points A, B, and C form a straight line. Remember, angles on a straight line 180 degrees. Oh, that. Alright, angles on a straight line 180. So that's it, we've proved it. That is a really lovely question. Again, we're playing with top grade C concepts, but not really anything more complicated. You just have to pick your way through the diagram carefully, pick up the angles you know, go for them and see what's left, and work your way around the angles as if you're playing snooker, and then hey, go for the proof and get it right. That's the end of chapter 7, and we'll see you in chapter 8 in due course.